right, everybody, let's get started with our keynote. So I am very, very pleased to introduce Dr. Ryan Janzen. He is a scientist, engineering researcher, and entrepreneur featured on the Discovery Channel, Wired Magazine, and through the Wormhole. Janzen's innovations have been featured in 110 plus international lectures, media interviews, and scientific publications. Janzen's work has led to entirely new fields of research, including extremissive optics, valence flux, swarm modulation, and the world's first aircraft PLC research. His innovations have led to advances in acoustics, aerospace electronics, mathematics, and vehicle propulsion. Janzen is co-founder and CTO of TransPod, designing a next generation of ultra-high-speed aerospace vehicles to move passengers and cargo between cities at over 1,000 kilometers per hour. Janzen is the chief architect of the multi-billion-dollar future system, transportation infrastructure operations, aerodynamics, propulsion, and avionics. So without further ado, I will pass it off to Dr. Ryan Janzen.
Okay, thank you very much, and it's a pleasure to be here. Thank you for the invitation, and it's always great to see the different teams and what everybody comes up with through the year. So first of all, I really wish you all good luck and with your projects, and I think I definitely applaud it, and really I'm a big supporter of work on projects across many different disciplines. So whether we're talking about many different disciplines of engineering and all the disciplines of engineering, and of course business, global issues and development, urban design, and architecture. And by the way, these are all things that are with TransPod. So I'll give you an explanation of what TransPod is and what we're doing around the world. And really, part of the point is to involve a lot of those disciplines working together and in really a holistic way to create a system that works in a practical sense, but incorporates some of the latest innovations that we've come up with and make them deployable across a few different industries too. So that we're in collaboration with the construction industry, with the propulsion systems, electrical systems, and so on, and also really incorporating a lot of environmental kind of design features too, and community benefits, and so that there's a lot of all of these disciplines that come together. So it's really great to see all the work that all of you are going to be doing over the next this year. So good job. So just a little bit about myself. So my background is from partly the research world, aerospace, some work in Silicon Valley. I've also started different companies, so serial entrepreneur kind of side, and all of this kind of comes together to create now TransPod. And so I'll show you a little bit about what that is. I'm going to show you some of the kind of neat technology behind TransPod and some other issues and a lot of the global development that is part of this project that we are working on. And also, I think, to give a few of you just some encouragement and advice and support with the endeavors that you're doing right now and you will do in the future, really to focus on the areas that where you can have the biggest impact, and so on your personal life and professional development, and you're really developing your passions and your hobbies too, because that's really what I look for with attracting some of the best people, the best experts from around the world to work on the TransPod project. So some of them are from Canada, some of them from the US, some of them quite a few from Europe, many other countries too. But the really key thing is finding the best and most creative, most practically minded, most good at collaborative work kind of people, and really all of those people are being drawn out and coming together to work on TransPod. So who knows, some of you might be involved in the future, and I think it's good to show a little bit of where we're at and what the next steps are. And really on the well, okay, so first things first, I will explain a little bit about TransPod. And so at this point, I'm going to share some visuals because there's a lot to see. So just bear with a little moment there. Okay, so now can everyone see the screen now?
Yes, we can.
Okay, excellent. Okay, so what I will start out with is just a little bit of an overview of just straight from the beginning. And so, you know, my own interest is really at the connection between new technology and things that affect people on a massive scale. And so that's definitely the case with transportation, because you can't just have an idea and but something that's not really deployable at a huge scale. And so with big infrastructure projects, there's a lot of financial and practical things you have to think about, but also the human aspect too. How does it affect people, and how do people want to travel? But really incorporating the latest research. And so so my name is Dr. Ryan Janzen, and like I said, so this is just going through this. That's kind of my background. That, like I said, and so that all has led up to TransPod. And TransPod is a new type of what I would call tube transportation. And so these are, by the way, I'll show you some of the exciting new stuff, because these are a little bit of an old, you know, from years ago. But really the core, and then I'll show you the latest technology that we've actually finally unveiled to the public of what we're really working on. So, but what I would say is that the overall, and you know, there are different words for it, or vacuum transportation, but that's the overall kind of field that we're all looking at here. I would say that Hyperloop is just one example of that. And so with the TransPod system, we have tried to develop something new that is a new type of tube transportation, or low pressure transportation, vacuum transportation. There have been other, even, you know, there's Swiss Metro, there were other kinds like ET3, and those are all different from Hyperloop. The core idea behind low pressure in a tube comes from about 100 years ago. So it was two people that kind of invented the idea sort of independently. There's a Russian professor, Boris Weinberg, and then there's one of the pioneers of rocket travel. They both kind of independently came up with that concept. But so what I'm going to show you is how this new TransPod system, it's not Hyperloop exactly, it's this new type of tube transportation. And you saw kind of those really old renderings, and so what's kind of exciting is some of the latest vehicle designs that we have just unveiled to the public, and I'll just show right here. So the exciting stuff that is where, oh yes, use slideshow, there we go. So it's this new thing that I've invented a few years ago, but has been very confidential up until now, which is called the FluxJet. And so I'm going to explain what that actually is, and soon. So you'll see. But the basic thing, when you look at it, it's a type of vehicle. It's a new type of vehicle that is a bit of a mix between an aircraft design, operates like a train, but what it actually has is a whole flight control system and some pretty advanced physics. So on the outside, it might seem like, okay, this is just tube transportation and so on, but it's actually the way we're designing it is kind of radically different. And some of that has been unveiled to the public, but some of the next, the special features have not yet been announced yet. So they'll be announced in soon. So it's all kind of coming one step at a time. But this is part of the TransPod system. And so we're actually using special type of propulsion system and a special type of power transfer that actually uses plasma, so matter in the plasma state. So you have solid, liquid, gas, and plasma. So we're using that's a pretty big breakthrough to be able to, and there's a reason behind that. But the basic thing is this vehicle is called the FlexJet, and you actually, that kind of pink purple glow there that you sort of see on the right image down here, that is some of the plasma. That's just a rendering, but we have basically, we've done experiments with all of these propulsion systems, testing them at over 1,100 kilometers per hour aerodynamic speed to really, because there are aerodynamics. You actually have, even with a somewhat low pressure, you still have, and so that's part of why we're working with a few aerodynamics experts, including one guy, Pierre Sagot, who's one of the guys who writes the textbooks on supersonic flow and shock waves and so on. But we actually have separate experts and our own team that have been developing this plasma technology. It all kind of fits together. And so it's a really big collaboration. So the TransPod team, so basically, so I'm the inventor of the FlexJet and the inventor of the overall system, or the designer of the overall system. And so our team is in Canada, and then some people in actually a couple of different locations in Europe, where we have kind of centers of excellence of our own team, plus some of these partners. So one example of, we're starting a collaboration with CERN, so you see over here. That's the particle accelerator that's underground between Switzerland and France. So they're where the Higgs boson was finally discovered. So there are a lot of these kind of special physics collaborations, also really with vehicle design, fuselage design, but also on high voltage power systems and so on. And actually, one example of that, it's amazing how a really big project involves a lot of work. So if we just imagine, just to see how the scale of this, just imagine, okay, the whole vehicle, like an aircraft, you have, when Boeing or Airbus designs a new aircraft, they have a lot of different subsystems over the whole thing, right? And so all of those units are a big design project on their own. So one example here for us is just this small thing within all the power systems on the vehicle, on this TransPod system and the FlexJet. You break it down, kind of a tree structure, right? And so then within the power systems is this primary power converter. And so this box here, it's kind of the size of, it'll fit on your dining room table, maybe at home. And it has enough power going through it to power 2,000 houses. And so it's all liquid cooled and with the latest silicon carbide technology, with all this high voltage control, very precise control, and some superconductivity, superconducting parts too. And so that even itself is a huge project. And so that was that involved a few different companies working with us, some of our team in Toronto and in Paris and in a few experts in Spain, and then a team in northern Italy. And that was just for this one box. So over the whole system. So you can see how all of these different parts have different partners working together. And actually you see just in the photo with the people standing there. So that's me with the blue shirt there. Just behind me is one of those. So all the wayside power systems for our TransPod line have all these high voltage, things, the wayside, like the railway kind of terminology. So it's you have to have power conversion along the way, along the route of the line. So that's a whole other ball game there. So all of this gets broken down, and so then how does it get developed? Well, when you think of all of these subsystems that are being put together at the same time, then you have to test them. And so we have been testing high speed, we actually have the equivalent of making the equivalent of a high altitude NASA experimental aircraft kind of environment. So we're actually able to recreate the conditions of that with high voltages in the kilovolt range, and the low pressures, and the high speed aerodynamics. So with all of the different test vehicles that we're building, there's a couple things coming next. So this is a picture of one where we have the construction permit approved, and we have actually started construction in central France. This is a half-scale test track, and maybe I'll just show. I think yeah, maybe this one would be kind of nice. Just to get a little sense of, it's a little bit similar for our bigger scale test track in Alberta that we're working with the Alberta government on. So this one in France, this is actually the architectural design where it's in a former rail corridor that was decommissioned. And so, and you actually see how it actually has some curves to it in the rail corridor, and we're actually able to take advantage of that because we're actually deliberately trying to kind of use the curves plus put our own curves in certain ways to actually test the vehicle dynamics as it does certain curves and slight turns and things like that. So this facility it's sort of like a test and assembly and control building, along with the actual main part of the test track. So this thing is actually half diameter. So our full guideway diameter is 4 meters. And so this is a 2-meter diameter, half diameter thing. And then in working with the Alberta government, so we're actually working on the next step, which is a full diameter test track for the final test, the final certification. And so what you do is you actually have, maybe I'll just stop sharing for a moment. You actually have, if you can still see me, okay, yes. So typically with the aircraft companies, so Airbus and Boeing, they actually usually build a couple of different models. So often it's about 3 when they're doing, at least 3 when they're doing a new aircraft design. And so they have one that is usually kind of a static model with all of the systems integrated and everything, and they do some kind of stress tests and things on it. There's often another one that is used for destructive testing. So they actually build if you can imagine a beautiful, it might be $100 million aircraft that they're building, and they put the wings into a vise, and they start to bend the wings as if you're in far worse than the worst storm that they're planning for, and they actually bend the wings in a really horrible angle until the whole aircraft basically explodes and breaks. And so that's a certain kind of destructive test that they have to do. And so it's the same with us. We have a sort of a sequence of test vehicles that at the full size that we're going to be putting through that that full-scale test track in Alberta. And then all the regulators that we're working with in Europe and US will all be kind of traveling there to kind of work together on the final certification. And so before that, it's I sort of sometimes say it's like a set of Russian dolls where you have, you know, those little dolls where you have a little one and then it fits in all these different sizes. And so our vehicles are being built in different sizes like that. So we have very small scale ones. We have the one for the that half diameter test track. That's another smaller one. That's a little bit more kind of just a frame, a modular frame where we're going to be kind of attaching different combinations of subsystems. And the nice thing with there's kind of a reason for half diameter, because if you imagine if you make the length half, the width half, and the height half, then you have about 1/8 of the overall volume, and the mass it's not quite 1/8, but it's a lot less mass, and that means that you can accelerate a lot more easily with the same amount of power. You can accelerate a lot better, so you have a shorter test track length. So it's a lot more logistically, you know, it makes the project easier to execute. So that's those test facilities, and then actually I'll talk about there's some interesting kind of I'll have a few takeaway. You know, maybe for some of you might be kind of inspired by a few sides of this. I'm going to show you a few more things in a moment, but there'll be a few little takeaways for a few of you on a couple of things on the that you'll get your ideas on. But I think the key is to really by showing you, I'll show you some things now that will also kind of stimulate your imagination, and I'm really seeing, you know, who there might be some of you that think about that more with your projects, and again, you know, we really kind of look for where the best talent is out there, and so it'd be interesting to see what all of you do with your final projects. Okay, so now if I share that again, what I want to do is show you a little bit of the process, and so this finally unveiling to the public this. Now I'm not sure if you can hear the sound. So that is a little bit of the announcement that was done a few months ago to finally unveil this FluxJet. And so, and by the way, I'm going to play a few other, can I just ask if the sound came through on that one or not? I'll play some
Yes,
other
it
things.
works.
Okay, good. Okay, great. Thank you very much. So now the really interesting thing there is that you know how I said that all those different scale models. So we actually have been building. There was another one that we unveiled to the public that was just a little bit smaller too, kind of just a demonstrator thing that is kind of yet a smaller scale version of this full vehicle. And actually, before I show the overall slides of that, maybe just this. Yeah, here I'll just show little parts of this actually.
The FluxJet is a bold innovation. I'm Mustafa Shaheen, Edmonton Global's Executive Vice President. Alberta contributes $330 billion to the economy of North America, and Edmonton is Canada's fastest growing region. The TransPod FluxJet line is an exciting project that will enhance regional connections and accelerate transportation at a massive scale.
The FluxJet is an exciting, major project that will put a global spotlight on Canada and Alberta. We look forward to participating in new industries and bold new projects that revolutionize transportation as we know it, to help us reach our net zero goals by 2050. The TransPod FluxJet line is that project. Our workers handle billions in construction work each year, and the TransPod line is ideal for construction at a mass scale. The FluxJet is a bold leap forward in technology that we're incredibly excited about and to be part of.
Okay, and that's
what's exciting about that is we're actually using plasma to get power to the vehicle. What the heck is plasma? Well, who here has seen the Northern Lights? Let's take a look. And that's actually plasma up there. So it glows. The FluxJet is harnessing plasma to make it work. And that is groundbreaking.
Okay, so that's just that was actually kind of chopped up a little bit, but you start to see a little bit of what excuse me with my throat, a little bit of this new vehicle design. And so when you see the kind of scaled down models, this is what it's actually representing. So this is the full FluxJet, and I'll show you how that works in a moment. But what I want to show you is just, again, a little bit.
Ladies and gentlemen, a baby FluxJet.
Okay, so that is just okay. So that
total Alberta.
I'm just going to pause on that because it's so this is just showing a little clips of that where we're showing that. And so what you see there is, and by the way, I think someone's microphone is on. Okay, thanks. And so that, and you see people kind of monitoring all the systems there, but it's full of computers inside and full of these propulsion systems. And I'll show more of kind of the theory behind that in a moment. But what you see there is you actually see these you see the angled things inside. So I'll just point with the mouse there. So that's one angled thing, that's another angled thing, and you see some stuff on the ends of those. So those angled things are what I'm kind of calling boom suspensions. So they're kind of they're kind of robotic arms, but boom suspensions that hold these propulsion systems and actually move them robotically. And there's a certain reason for that. If you read the patents, so it's a patent on the world's first predictive suspension system. And what's that? Well, that is if you take, I mean, I'll just kind of show you up close.
So there's no contact.
First of all, what
so it's
some of those
in real time and lifting this 1 ton of weight. So it's like
okay, so some of those levitation systems there, like that, that's kind of a let's just zoom out again. So what's going on is that it actually has linear motors on some of those boom suspensions down here for propulsion forward and backward, and then levitation systems here. And so they all, what the whole thing does is it's able to rotate and cant the vehicle and make it go up and down, or make the vehicle go straight while the infrastructure is going up and down at high speed. Now that's kind of the basic thing. But what a predictive suspension system is, it's the world's first system like that, and patented. So this is going to be the only one. Basically, we have this, which is really essential for any kind of tube transportation. And so we have the world's only system that is actually successfully able to do this. And what it is when you have the infrastructure, you're going at high speed, you have to go fairly, straight line. So if you're in a car driving on the highway, then it's not too bad, because if the asphalt kind of has a few millimeters up and down, that's okay, because you're just going on a car, you're going maybe at 100 kilometers per hour, whatever it is, which is a relatively low speed compared to this. So that's okay. But when you are going at over 1,000 kilometers per hour, then tiny little changes are very, very aggressive and bumpy for the passengers, but also very potentially damaging for the propulsion systems when you have magnetic gaps. And so this is a suspension system that actually does one step better than the, so in your car, you have usually a passive suspension. So it has kind of a response where it dampens it's like a damping mechanism. And so you try to, for people, if people who have a mechanical engineering class, maybe you have a critical damping, that kind of thing. So that's a passive suspension system. Then a few years ago, there was this new thing called an active suspension. So it's controlled, which is fine. And so that kind of, it goes up and down it kind of helps, it kind of power assist sort of thing. This is the world's first predictive suspension. What is that? Well, that's kind of like if you're flying in a plane, and when there's a little bit of turbulence. So the flight control system, the autopilot, when it's activated, it automatically makes the ailerons and the rudder and everything go up and down in response to that. So you feel some, let's say you're in a storm, and or you encounter there's a little bit of turbulence all of a sudden. Well, the plane rocks around and it stabilizes itself in a moment, right? And that's in response. But with a predictive suspension, now it's as if the plane can predict the future. So it's as if it's not actually predicting the future, but it's as if it knows the turbulence that's coming up ahead before it happens. And that's to actually more accurately stabilize in advance. And that's really essential when you're going at 1,000 kilometers per hour. Just to protect these sensitive linear motors and so on. And so what it's doing is it's actually passing on messages and dynamically updating databases in the vehicles and on the line control system of the track profile, even as it slightly distorts with the sunlight expanding and contracting things through the day. And so that is, and it's all this linear, the math behind it is kind of interesting, but anyway, it's the world's first predictive suspension system. And so that's just one little part of it, of the overall stuff there. And so, but then meanwhile, another part is this plasma technology. And so I don't know if this video has some of the high-speed demonstrations of it, but anyway, this other video, I'm just going to show you. Okay, so I'll just show you how, okay, that vehicle that you just saw the pictures of, with people sitting in front of it. Now see how it compares to the full FluxJet, which is bigger. And so that has that amount of space there for passengers or for cargo. And so it's designed to dock at stations. And so the TransPod station design, I'll say it's kind of like a a train station, high-speed train station or subway station. Okay, and then we start going, and so what's special? This is another reason why this is not Hyperloop anymore. So that's so for me, Hyperloop is kind of a different thing, or it's a little bit older kind of philosophy, but a different type of tube transportation mixed with this is completely different because it's sort of an atmospheric guideway here for interurban travel. And so meanwhile, once we want to get into this high-speed section, then okay, now it's tube transportation in a way, and so then we go into this through the airlock into this high-speed zone, and so then I'm just going to oh yeah, okay, so now we want to see when it gets into the high-speed section, switching power over to receive power from the grid using this plasma system. And so there's a lot of science behind how that is working. And so this, I'm just gonna show you kind of the interesting parts here. So these linear motors, by the way, we actually have, this is a simplification. We have a little bit of a more advanced system even yet than this, but this just shows the moving magnetic fields that are created by a linear induction motor. And and you actually see, I mean, it's pretty neat, the design of the different the optimization of the pole systems and everything like that. There's a lot of but anyway, it's making a moving magnetic field that pushes it forward. And so then maybe another interesting thing, let's just show you this. Yeah, okay, so this valence flux. So that's a whole other new technology. And so what it's basically part of the flight control system and part of the predictive suspension. And so it's what valence flux is. It's it's another new breakthrough in physics where you're actually seeing sight and sensing itself. Sensing itself. That's what valence flux is for. So it's not just sensors, but it's sensors of sensors. And so with valence flux, we can actually track the ability to see and the ability to sense through space, and we can actually see what we don't see, and we can see and this is partly for safety reasons at high speed. So we need to be able to size up what all the sensors are doing and see if there's any potential thing that we need, imperfection in the track or thing that we need to avoid at high speed. And that's really where we need to use valence. So you can actually look that up. There's a lot of papers on valence flux. So if anyone is interested, I can send more information about that afterwards. And so then we are up to full speed. Okay, so that is a little basic sense, and yeah, you kind of, I mean, just to reiterate, it's kind of neat to see the difference in or the scale of how this, and basically when you saw those boom suspensions, just imagine that central area, the center fuselage, is really stretched the most. That's the biggest change, but then everything else is scaled up for this full scale vehicle. So there you go. And then if we just go back here, what I want to do is yeah, just really kind of explain. So and as a company, so we've kind of part of it is transportation, but really part of it is is really technological innovation. And so working with universities, working with the biggest research agencies, and then partly developing this overall system, and partly working with many other partners on that. And then there's a few of us that started this company, and then basically we're working on the business side too. So maybe I should say also that the FluxJet, the reason why it's called the FluxJet is it's combining the electric flux from the plasma, so contactless plasma, magnetic flux for the propulsion, and valence flux. So electric flux, magnetic flux, and valence flux. That's the secret behind, well, I mean, a summary of the secret behind the FluxJet, but there's a lot of cool stuff that actually makes that work. And so yeah, so then it really goes together like that, and really so it's the vehicle but also the infrastructure that kind of makes it work. And so oh yeah, so that's part of the announcement there. And then meanwhile, part of the exciting thing with the Alberta project is just it's actually a full working with the Alberta government on a full line between Calgary and Edmonton. And then this test track is going to be a part of that. So you build the test track first, and then you extend it for the full line afterwards. And so we're also working with the state of Texas transportation authorities on a line there. So kind of early funding and studies. Also in Australia and in the UAE. Now the interesting thing with the UAE context is that you have major cities there, so Abu Dhabi and Dubai, where the airports need connections. And so part of it is to connect local airport connections, but also the intercity travel. And so overall, that timeline, and by the way, I'll show you. I think we can take a lot of questions here, and I think there will be a lot to show you on some of the other parts of the technology. But basically, the timeline going ahead is there's a lot of steps to bring together, but it's really towards testing and certification that is part of it. So and then it really all gets tied together because we're trying to create. And by the way, if anyone has a better word than tube transportation, you can say vacuum transportation or vac train, but it's a little bit more of a some people might get confused by it, or it sounds a little more aggressive. So there's lots of options, but it's really open to people's concepts of that. So really, I think, and I'd love to show so much more. If anyone has any other questions about and by the way, the interiors of the vehicle, that's not as critical of a thing. Some of the acceleration profiles, some of the real-time control, there's even a little bit of machine learning parts, but my philosophy is really it has to be deterministic as the primary method. And then some of this, some of the aerodynamics. This is actually hurricane force winds on the side of our infrastructure. Where we have to, so you kind of have to design it for a 500-year storm and really withstand earthquakes and so on, vibrations of the infrastructure and so on. So yeah, so I guess that's really an overview. And so what I'd love to do is take questions from people now, and there's so much to show, but I think it would be great to kind of get people's to see what people are interested in the most, and maybe afterwards I'll give, if people want, I'll give a few more words about kind of any other inspiring things and stories to tell about starting companies and my advice to people. So thank you very much for being here, and I'd be happy to take some questions right now.
Amazing, thank you so much. So we have a couple of questions in the chat from Alex. So the first one is, based on 2 power requirements you mentioned offhand, this will cost around $5,000 per hour to operate, excluding compressor requirements. How will you compete against other offerings when the ticket price is $90 to $150 just for the power?
Maybe you could show me your calculations sometime. But actually, the short summary is there's been a very careful analysis of all of the costs, at least for the TransPod line. It might be different depending on what kind of system you're basing it on, but at least for a TransPod line. So if you go through all the calculations of the operating, you have to think about the operating, even the staffing, operating expenses that also include, maintenance, line operations, and definitely power, like you said. So then it actually works out. It actually makes a profit. So then the break-even time is actually pretty decent. I mean, some of that is confidential, but the amazing thing is when, at least part of the reason why we've kind of spent a lot of time trying to do some special things with the technology behind the TransPod line to get some special advantages with the amount of costs for construction, costs for power and other operations, which actually is why we've been able to attract this private sector funding. So we don't have to put it, these funding partners actually will make money off of it. But definitely feel free to, if anyone wants to put some, like if you're working on part of a project and have all your calculations, you want to say, if there's time at some point, maybe I or someone on the team, on my team can kind of go through that, and if you have any questions.
Awesome. So the next question from Alex is, how much are you estimating the full-scale project will cost per kilometer based on your team's projections? We are estimating 50 to 100 million per kilometer.
Oh, I see. And maybe a question, is that for, I guess you'll have to say what assumptions you're like, is that for, because if you probably had certain assumptions about maybe certain some of the old Hyperloop proposals that have been out there. So I guess it depends on.
Alex, do you want to elaborate on that a bit if you can?
Sure. So just for some context, we were basing our estimations on how much it costs to build a pipeline, and that kind of factors into account the material costs, installation costs, land acquisition costs, etc. And we say a traditional high-speed rail is about $10 million per kilometer. That's just the ballpark figure people use. But once you add on a vacuum tube and you add on compressor stations and you add on all the auxiliary equipment to run something like this, we are like saying it's probably about 50 million on the low end, 100 million on the reasonable end per kilometer, just to get all the land you need, all the piping you need, because 4-meter wide pipe is not readily available. It all has to be custom made. And then just the tooling costs are pretty expensive.
Yes, like I think it. We have a team that does some pretty detailed financial or infrastructure costing with actually some pretty major construction companies. So that's part of now we have kind of an in with some of these there are a couple of big it's kind of I can't reveal yet. We haven't yet announced all of the partners yet, but basically civil engineering and construction firms. And so with one interesting just as a summary, we're actually able to there's a certain strategy where we're able to save a lot on the property acquisition costs. And also one thing that's unique about a TransPod line is that the infrastructure is quite a bit simplified. So that means that the infrastructure cost is the overall cost becomes about high-speed rail territory, a little bit above, and part of it is the fact that we're able to make it kind of a lightweight, on the structural side, a lightweight kind of system. And so then a lot of the costs are with the vehicles, but the vehicles are relatively, or a lot of the technology is with the vehicles, so the overall cost is of the infrastructure at least is lower. But yeah, so that's, I mean, that's kind of a long rambling answer, but we actually have some costing that's on the website that you can read about if you want.
Cool, thank you very much. Is it possible I could, chat with your team just to see how they're doing their math and just, compare notes, since we have such wildly differing estimations?
Possibly. I mean, there would be. I mean, some of that information is
confidential, of course.
Confidential at this point. So, but I think what we'll probably be doing is like as we go along, we release certain things to the public once it's ready, or once it's not confidential anymore.
Cool. Thank you very much.
Sure.
Sanchit, did you have a question? Your hand is raised.
Yeah, so if I may ask, so thank you, sir. It was a very wonderful presentation. So I have like two questions. First of all is that you presented FluxJet as a modified version of the Hyperloop, which is certainly acceptable. And when I was reading about your company, I came to know that you all have done feasibility studies in Alberta and in France as well. And you mentioned that in one of your slides. Apart from that, sir, recently we went to the European Hyperloop Week, and there we met Heart Hyperloop, so which is also working on a similar line between Amsterdam and Paris, which lies in France. So my question is that, is there a possibility of a collaboration between these two stakeholders, like Heart Hyperloop as well as TransPod, which would be beneficial for the whole of Europe?
That's, you know what, that's a great question. So there actually is some good collaborations going on, and that is actually more on the regulatory side of things. And so I think meanwhile, with this Canadian technology now, we've or with the TransPod line, we've identified, part of the strategy is we have something now where we can actually, we believe can become a very competitive system compared to some of those other designs. But that doesn't mean we can't still do very good collaborations, at least on the regulatory side. And what part of what I'm trying to do there is make sure that everyone's voices come together and everyone's designs are kind of accounted for nicely, so that when the regulators are doing all that work, they don't kind of make some kind of standard and then someone's design is not allowed or something like that. And so we're trying, that's where I would call, when I go to Brussels, so at the EU regulatory level, I really talk about technology agnostic kind of way of doing it. And so actually, if you're interested, maybe I'll just this is kind of fun because it might actually get some ideas from some people. So I'll just share this on the screen. So if we to transportation or VAC-train or whatever it is, not necessarily Hyperloop, not necessarily TransPod, but whatever it is. So if you break it down, we're trying to make it technology or implementation independent, or implementation independent, or technology agnostic. So you have the vehicle and infrastructure. And so if you break it down, what we try to do is, because same as that kind of thing. And so what it's trying to do is have a very, basically no matter who's designing something, it can all account for that. So so what's in common, and maybe I think with all of the things that all of you guys are thinking about, what you can do is think about, just to see, its challenge to you is if you can think of anything that's not part of these things. So what this is trying to do is come up with 12 different functional blocks, so kind of a functional breakdown of everything that's there. And so, so for example, rather than saying like a tube or whatever, they're part of what the TransPod line is. It's not just a tube. Like there's some other aspects of it that are kind of fancy, that are different than Hyperloop. And so it's, in general, it's route, structure, and enclosure, and has all these different things. And then what it's trying to do is have examples of how you can do it, but that's not to say everyone has to do it that way. And so same with low pressure environment control, stations and infrastructure to support them, and then the maintenance functions, because this is not a system, it's like a function. And then the functions of a vehicle structure, internal environment with pressure control, temperature control, so on. Maintenance and storage of the vehicles. And then one of the big things that a lot of the regulators, they don't understand the difference between movement and forces. And so what this is trying to make sure they understand is that, to be most general, whenever you have either brakes or linear motors or anything, even aerodynamic forces, they provide forces. Force is different than motion, and that's one of the biggest things I've had to explain to them, and the difference between longitudinal and transverse. So this is along the direction that you're going. For us, that's like the x-axis, and then the y and z axes are this. And so because you want to make it, no matter who's designing something, you want to make it be very generalized, so that, you know, whatever the propulsion, whatever or if you have some kind of passive system, it all works, it all is kind of accounted for. And then energy management, because you don't want to say, oh, it has to be with batteries, or it has to be with a power pickup, or it has to be with, you know, whatever. Just, you have to manage the energy, and command, control, communication, and signaling, and emergency management. And so then it all breaks down. So anyway, that is what huge amount of committees and work that we've been doing in Europe right now, just to make sure we have. And by the way, suddenly in Canada, it's possible that the Canadian regulations may actually start to go faster than in Europe even. So it's all of this is a big project to get the certification ready. So that's a good collaboration.
Okay, thanks a lot, sir.
Yeah, yeah, and so I maybe I'll, to everyone there, I think if anyone, feel free to put out ideas if you see anything missing, or if you have any, even with the whole concept of tube transportation or vacuum transportation, vac train, anything like that. If you have any nice ideas of words that would be great for kind of a general summary of what this whole field really is, technology agnostic, then feel free to reach out.
Awesome. Andres, you have a question.
Yeah, thank you. Hi. I had two, but I think that the session ends at 2 p.m., so I'm just going to ask the second one. First of all, thank you for the presentation. It was really great. I think most of the people in attendance here are university students, and obviously we have an interest in tube transportation. What I've noticed though is, like, it seems that since it's such like a novel concept, and like you mentioned yourself, you're trying to recruit like experts in aerodynamics or in whatever, right? So what would you recommend for us as we get out of university to kind of like build our resume to the point where we're able to enter the tube transportation industry?
Right. Okay. Excellent question. That's a perfect one to end on. So what I really recommend is for everybody to really pursue things where your passions are lined up with your abilities. And so doing things that you really, and so for example, not necessarily only just doing, you know, the projects that you're supposed to do in this course, that course, but if you have some kind of really amazing, so, you know, the projects you're doing here, something outside of class, that's great. really focusing on the things, not just any of your abilities. I think if at least with when I'm kind of looking at all these resumes that come in, it's really not just the resume, it's all the portfolio of, you know, what can the person really do that really comes alive. And that's kind of like finding things where you're not just doing something that you're fairly good at, because there are thousands or even millions of people out there that might be fairly good at that thing. But something, if you can do something where you can become the best in the world at that one thing, whatever it is, and if you like doing it too, that's where it and so that's where you can make an amazing impact out there. Whether you're working on a bigger project, whether you're starting your own project, it doesn't matter. But if you kind of focus on all the things you're learning, but your own kind of skills or your own unique things that you're developing, that maybe you're it's okay if you're like kind of good at this, kind of good at that, pretty good at this, not so good at that, and then you have one thing that you're really good at, and you can kind of make that all come together. And whether if you're in engineering, if you want to design and build those things, I'm always looking for people that can actually create things on their own, like a finished project, not just you're a tiny cog in a machine of, or not like a one part of a big team. It's good to be part of a team, but I like to see examples of a couple of things where you can say, that one thing I did by myself and I could do the whole thing. Then that's really amazing. So kind of putting together all the things you're learning in school, but also your own hobbies and passions where you can really make a big impact, and then making that be like your portfolio and just send it into TransPod.